have to restrain myself. Dr. Obeid has a number of different roles at the MUSC. He is co-director of Biomedical Informatics for their CTSA, and in that role runs a number of systems that many of us have across the country, including REDCap, an I2B2-based data warehouse, Harvard Profiles, which is sort of equivalent to our Pure system, Elsevier Pure system. He's also associate professor in the Department of Public Health Sciences and heads the Division of Biomedical Informatics within that department. And for years, I thought he was a psychiatrist because he also has an appointment in psychiatry. And so whenever he nodded, when we were talking about something, he nodded wisely and said, "Tell me more about that." I thought he was analyzing it. And he was just being polite.
And you feel like you're in a session.
Exactly. Well, he's such supportive and kind that he sort of. Dr. Obeid got his formal informatics training from the Harvard MIT program in the Division of Health Science and Technology. And with that, I will let him take over.
Thank you. Thank you, Elmer, for that kind introduction. One thing you forgot to mention is that I'm originally a pediatrician. And so I was a pediatrician before I became informatics, but my love for computers came way before I became a pediatrician. So I am in South Carolina. Let me learn how to use this thing. So this is Charleston for those of you who haven't been there. This is the view from our Rutledge Tower, and it's one of the big buildings and one of the biggest buildings in Charleston. This is as big as buildings get in Charleston. But
it's a very beautiful city.
It's a beautiful city. Yeah, you should come down and visit if you can. So this is just a rough outline, and it's not very accurate because I am going to give you a little bit of introduction and history of where we're coming from. A lot of infrastructure projects, but there's a lot of research embedded within those, informatics research embedded within those infrastructure projects. So then just a quick overview of what else is happening on campus. It might look to you like a scatterbrain presentation, but as Elmer knows, if you have your hand in a CTSA, you're doing everything across the board. So that's why it's a disclaimer. It's going to look like a very, disjointed presentation. So here's a little bit of background. So our center is called Biomedical Informatics Center. It has significant sources of funding, different sources of funding, but primarily we're funded by two main initiatives. One of them is a statewide initiative, and the other is the CTSA initiative, which is not all the money comes from the NIH. As you know, with CTSAs, the institution has to invest quite a bit. So our CTSA institution is called Sector, which is short for South Carolina Clinical and Translational Research Institute. The other entity that you might have heard about is called Health Sciences South Carolina, which is a statewide entity, which is funded by a philanthropic entity that's called the Duke Endowment, which is basically tobacco money from North Carolina, but funds projects both in South Carolina and North Carolina and across both states. So HSSC, Health Sciences South Carolina, HSSC for short, is a collaboration between the major medical institutions in the state and three universities, and that's Clemson University, University of South Carolina, and Medical University of South Carolina. Now, MUSC and USC are not the same university. You might think that they have the same name, but they're actually not the same university. They're independent of each other, and MUSC is more of a health care institution. It has six different colleges in it, including College of Medicine, Pharmacy, Nursing, and all of those. There are other sources of funding, your typical NIH collaborative NIH grants with other researchers on campus. And there's also some what we call smart state funding, which is basically centers of excellence which are sort of endowments from the state to fund different research projects, including informatics. Because we serve a statewide entity, we are a statewide distributed organization, the BMIC, or Biomedical Informatics Center for short. We are mostly based at MUSC, so all the faculty in informatics are at MUSC. We do have some project managers in the HSSC offices in Columbia. We have our statewide servers running out of Clemson. Clemson is really good at running a data center. They run the CMS data center for, what is that? Anyway, sorry. It goes, so they're running our statewide data warehouse. They run our EIRB system. And so a lot of servers run at Clemson. We do have our own data center, which runs our own EHR and our own EDW. And I'll talk about those in a minute. So this is what the timeline looks like. Health Sciences South Carolina was founded by your current provost, Dr. Ray Greenberg. He's the brainchild behind it. So he was our CEO at MUSC before he came to the UT system. He, along with the other CEOs of the other institutions I showed you earlier, established this Health Sciences South Carolina, and then eventually we got funding for it from the Duke Endowment. And a few years later, we started this. I wasn't there yet. I came right around when the Biomedical Informatics program got started. And things started taking off from there. We started planning. Right when I arrived, I helped with the writing of the CTSA application. Jim was also involved in that, Jim Zhang here. And we got our first grant in mid-2009. And then, you all are familiar with ERA funding. We got some ERA funding for one of our projects, and things evolved from there. We had Smart State funding started to kick in. We had a second round of Duke Endowment for HSSC. Eventually, we established the Biomedical Informatics Center. And at that point, we had only 2 faculty. When we started out with one, Ian Sanderson was there before I was there, but we had no staff. So by that time, with all the funding that we had and the statewide dependencies or statewide projects that we were funded for, we built up our team to about 25 plus staff and more project managers. Eventually, we went live with the statewide HSSC data warehouse with an I2B2 instance. Later on, we recruited, after Ian left in 2012, we recruited Dr. Les Leonard as a CRIO. So this was the first founding position for a CRIO at MUSC. And he's leading a lot of huge initiatives, wonderful initiatives within EPIC, and I'll mention some of those as well. We got our CTSA renewed recently, and a third round, but with a wider scope of a Carolinas collaborative project that is a grant for HSSC as well with the Duke Endowment. And now we have 7 faculty, and we established the division within public health sciences of biomedical informatics. So I thought it's just an interesting thing to show you how we evolved over time, given the title of the presentation. So this is our portfolio, and I'm showing some of the things here, but you're probably familiar with all of those because it looks very similar to many CTSA institutions around the country. But we have, maybe what's unique to us is that we run the IRB system. We have because we do that, we were able to mine data and extract data from it. into a clinical trials registry for patients, and then the REDCap, a data warehouse. We created this new platform, which is basically a request system. It started out as a request system for CTSA services, but evolved significantly since then. I2B2 and Palmetto Profiles, which is our instance of Harvard Profiles, your equivalent to your pure SciVal or Elsevier product. So I'm going to start with some of the infrastructure projects. REDCap, just to show how we evolved quite a bit since we started out in 2009. We were one of the, although we're a small institution, we're one of the most active users of REDCap after Vanderbilt. And most of the projects in it are within, there's a lot of QI projects, but also within the research, there's a lot of clinical research going on with REDCap. The clinical data warehouse, so this is the statewide one that went live in 2013. We were talking about that last night. We have about 4 million patients statewide within it, 34 million encounters. And it includes currently many different health systems. We have Greenville on board, that's in the upstate, Spartanburg, a couple of institutions in Columbia, the capital, and of course MUSC in Charleston. And more are coming on board. So we established a governance for that. We have, we started out with live feeds, but now we have also batch feeds going into the data warehouse from other local EDWs at the various institutions. So we have statewide governance that would not have happened. The data warehouse could not have happened without that. All of that is based on something called the Data Collaborative Agreement, which is hammered out by the lawyers across the whole all the institutions, led by one lawyer that was hired by HSSC money. And he did a wonderful job getting the lawyers together, talking to all the CEOs. This had to, the board of HSSC is made out of all the CEOs of the different institutions. So you have to have buy-in from very high up, and then you have to have committees that involve people from across the different institutions. What this doesn't show you is the governance committee, and there's also a steering committee made out of the deans and the provosts. The board is made out of the CEOs. There's a data review committee that has a representation from all the institutions, an honest broker mechanism run out of Columbia, and I am the PI on the IRB protocol, which allows us to use this whole thing for research. And we have the usual infrastructure for managing a data warehouse. And then we have advisory group for things like advisement on regulatory issues, like the IRB group, security group, and the data quality group. So this is what the data collaboration agreement looks like. It's basically the legal agreements that had to be in place for all of this to happen statewide. There's a lot of BAAs, and they have to be between all the institutions that are sharing the data and the institutions that are looking at the data. And our services, as I mentioned, are in Clemson. Our chief security officer is also from Clemson for this, for HSSC. And initially we started out with help from Recombinant, but they only worked with us for a couple of years. But that was also included in the data collaboration agreement. So this is a cartoon of what the data warehouse looks like. So it has feeds from all the institutions. We have an operational data store from which we create data marts, and then a star schema here. and from which we create data marts. One is that's de-identified for I2B2, and there are some other data marts more recently created for things like QI that we give back to the institutions. And as you can imagine, I mean, this simplifies things. There's a lot of work that went on with harmonization of HL7 messages. And, you know, HL7, you might think of it as a standard, but for those of you who've worked with HL7, people can store different types of information within the messages. So it was a big deal trying to figure out, you know, and tailor the messages that we're getting in from different institutions so that they so that they pool the data in appropriate fields using standards. So we mapped to RX norm from all the different systems. We also used the HL7 demographics standard to map to the demographics. And we're doing labs. Labs have not gone live yet, but we're mapping labs from all of the institutions to LOINC. We're starting with the most common labs. So this is what the scope of the data warehouse looks like, the statewide one. And it includes patient demographics. That was the first thing that went live, is the ADT messages and encounters, diagnosis and procedures. So all of these up to this line were included with the first iteration of the data warehouse. After that, medications about 6 months later were added. And now we're working on labs. Hopefully that will go live by the end of, I would say, Q1 2016. This is what the IRB process looks like. I mean, I just put a schematic to it, but I'm sure everyone is doing the same thing across the CTSA network. So in the IRB protocol, I divided it into two arms. We can talk about arms because we're talking to researchers. So the two arms are the de-identified arm, where people can look at totally de-identified aggregate data. And all you need for that part is an IRB waiver. And for sharing the data, patient waivers. You don't need consents or anything like that. For this part, however, we basically are outsourcing the consents and the IRB approvals to the researchers themselves. So we approved the process, which is the honest broker process by the IRB, and we just did that to be on the conservative side. Many institutions don't do that, but we started early on with that, and we decided to play it conservative, submitted a full IRB protocol that includes both these arms to the IRB. And so the IRB now are familiar with the data warehouse, and they know what to look for when they see protocols that require the use of the data warehouse. Over time, things became a little more complicated. So now we have actually the MUSC data warehouse, which also we call the CDW, went live before the HSSC. It actually went live in 2011. Which has a similar, approval process. We approved it first for MUSC locally, which has a similar infrastructure but does not use I2B2. It used a homegrown BI tool. Right now we have data coming in from Epic into our CDW. We also have Slicer Dicer, which is, I don't know how many of you are familiar with Slicer Dicer. Okay, so Slicer Dicer is the I2B2 for Epic. So it's a vendor-specific, Epic-specific tool that allows you to, it has a GUI interface, basically, that you can drag and drop different criteria, and it shows you bars instead of numbers. So it's a really cool, I mean, it's a nice tool. But it's not, I don't think it's as powerful as I2B2. And so the people, researchers today have the option of going to either Slicer Dicer or our query tools like I2B2 or other, the BI tool that we put in place early on. So they have different choices to get their own data. And then if they want brokered data, they go through an honest broker. They go through a sort of a consultative process to figure out where best to get their data from. And then we can get them data either directly from Epic. Sometimes they are only asking for Epic reports for research. Or they can get data directly from the data warehouse. For I2B2, we also have some research-specific data marts, and these have their own different funding, the different governance, and they are funded with research-specific projects, and they are more disease-specific projects. So we have one for a rheumatology P60 grant. We have one that's funded by the Alpha-1 Foundation for Alpha-1 specific for Alpha-1 disease, and Alpha-1 antitrypsin deficiency. And we have one that we're now building for a stroke Rehab registry, and that's also NIH funded through an idea state mechanism. But they all look very similar in that they have REDCap for data entry with data feeds from an EDW. We're using the REDCap DDP, if you're familiar with that data pull mechanism. And then we create a data mart from that, and we express a much richer I2B2 mart than you would in the typical data warehouse. So this one could be identified or de-identified, but only the people who are on the IRB protocol for this specific project can access this data mart. So what else are we doing with our EHR data? As many of you across the CTSA network are doing, we have collaborations with many of our colleagues across the CTSA network. One of the first Shrine instance that we created was with the Carolinas, our friends in North Carolina. I don't know if you've heard about Shrine, but it's basically a federated system. You know, I2B2 was developed through one of the NCBC, National Centers for Biomedical Computing grants at Harvard, and Shrine also was developed at Harvard. Both of them are open source projects released to the CTSA community, and Shrine has become the de facto standard sort of for federating data across multiple institutions. So we're using that as well, and we established a pilot with Duke, UNC, and HSSC, and Wake Forest. Our pilot was using just a proof of concept pilot using stroke data. But since then, we have established many other regional networks, including a network with a regional network with UAB, Jim Semino, and Arkansas, and Emory. More may come on board, but right now that's, and that includes MUSC data and from those other institutions. We're also part of the ACT network, which is, the CTSA network. So we have many different Shrine connectors to all of these different networks. All right, so a little bit, one of the things that we did early on was a lot of work in the consent informatics area. One of the first projects that we did, this is the one that I mentioned was funded by an ARA grant back in 2009, American Recovery Act, if you remember those. So we funded this through an RC2 mechanism, a GO grant. And it was a grant to create an electronic consent infrastructure. We did that. There were many collaborators on this project. We had Duke working with us on the ethical legal stuff. They have a superb ethics group there that worked with us on that. We partnered with some industry partners as well. That was not very, maybe I should strike that off the record, but suffice it to say, it wasn't very rewarding to work with industry partners on that. So we brought a lot of the work in-house, and I think the project took off much better after that. We were able to roll out a pilot mechanism for capturing consent at MUSC. And what we did, we piloted it on a consent to treat mechanism, but it was only a pilot, never went into production. What we did is captured our research permissions within the consent to treat using this system called RPMS, or Research Permissions Management System. And so the idea was that a patient would be registered, and the data would go through our registration system. This was before EPIC was implemented at MUSC. And from there, it was fed to our HSSC data warehouse, an early version of it, where we have a master patient index that would basically deduplicate patient records. And we would send it back through HL7 messages to, the HL7 message was sent from the registration system to our NPI, and then we push the data back into our PMS, where we express the consent forms that were needed for the consent to treat. The nice thing about this now is that, unlike on paper, now you can collect those check boxes, yes, no, you can collect them as discrete data elements and feed them back to the data warehouse. And if you want, express them in I2B2 as a research permission. So there was a little bit of ontology work involved with this. So it was an interesting project overall. The other thing is that we had to be, one of the requirements was to be able to reproduce the paper form and give it to the patient when they came to sign the consent. So they signed it electronically, but they got a paper copy with a signature on it. So the pilot was well received. We had a couple of publications on that. And there was some early consent ontology work on that, but it's evolved significantly since then. I'm working now on ICO, which is the Informed Consent Ontology, led out of University of Michigan by Frank Mannion. So we're trying to leverage some of the early work we did here into the new ICO, on Informed Consent Ontology. So and fast forward to 2015, now we're capturing research permissions within EPIC. So we're using EPIC MyChart now to do a consent, research permissions, those yeses and nos that I mentioned earlier. One of the main questions, the important questions that we ask is whether people are okay with us contacting them if we found a eligibility criteria that, if their EHR data matches certain eligibility criteria for research. So, the traditional way that you do that, the IRB approved way, IRB hates it when you apply for protocols that they don't like this thing called cold calling patients. So if they don't like patients getting calls out of the blue from somebody that they don't know for recruitment. So the traditional IRB approved recruitment is that you have to go through the physician, the patient's physician, to recruit them. So if they came to your service at your hospital, you're allowed to recruit them. So this permission, is it okay to contact you for research, allows us to bypass that. And now it's more of an opt-in. So we're sending them a questionnaire through the EPIC research portal called MyChart. And then they read that carefully, and if they agree, they say, yes, it's okay to contact them for research. The other question was around using specimens for de-identified linking to EHR data, discarded specimens. So here's the results of this. And so now, finally, research permissions are in production through EPIC. And it was much easier implementing them this way rather than introducing a third-party system. We designed the questionnaires ourselves, but we worked closely with EPIC to be able to do that. We have a superb EPIC research team on our staff. And we were able to see what, get some basic statistics from those two questionnaires that we asked. And surprisingly, I don't know if you've seen the data coming out of Vanderbilt, where they had an opt-out system that collects, Hawaii, you probably know about that, for their BioView system. And the BioView also was an opt-out biobank system. And the opt-out rate from there, so I would say the people who agreed to participate in the biobank were somewhere around 85%. Well, we're getting very close to that with an opt-in, which was surprising. But the only caveat to that is that we only had 40% response rate. So people who do think about whether they're going to, think about research tend to be altruistic and volunteer for research, which is an important thing to do. Another project that is based on our early work in electronic consent is this thing called teleconsent. So we have a brilliant young guy who came to us from Utah who's working, Brandon Welsh, who's working, who is an expert on telehealth. He founded this company called DoxyMe, which is a telehealth, very lightweight telehealth, freely available system, which allows you to log in as a patient and talk to your physician remotely. So when Brendan came on board, he knew that we do work in consent, and one of the important use cases for that electronic consent can solve is the idea of consenting people remotely. So we said, why don't we combine telehealth with consent? And so we did that, and we developed a system called teleconsent, so basically what we did is we added document management system to DoxyMe, where a researcher can choose the consent forms to express within DoxyMe, and they can guide the patient through the consent forms online. You can also do a digital signature through that. So the patient logs in on one side, the researcher logs in on the other side. Sorry, this is the participant, this is the researcher. And then we can get the requirement here is that the patient can print out the consent on their side, and the researcher can print out the consent or save the electronic version into their system of record. Yeah.
So what does DoxyMe actually give you? It seems like it's just the interface, or?
DoxyMe is the telehealth system, so it gives you a video link.
Oh, so this is synchronous.
Correct. Yes, and this is what this is what it looks like. Actually, I didn't.
Video on the.
Correct.
Okay.
So what I didn't show is the previous screen to this because it's a long talk. But before you see the consent form, you actually have the patient. On the patient side, you see a full screen of the researcher. On the researcher side, you see a full screen of the patient. Once you bring up the consent form, they go to the corners, and they can navigate through the document simultaneously, synchronously. So if somebody is highlighting one area of the consent form, the other one can see where they're highlighting. So you can actually guide them. It's sort of like sitting next to the patient and highlight. That's the novel thing about this, and it includes an electronic signature. And there's two options for electronic signature, either a signed, with a pen and a pad, or with a legally approved, we approved this by our legal department and our IRB, where you can get a snapshot of the patient and it captures a snapshot of the date. It captures also a date and timestamp with this. And there's also an audit trail that prints at the end of the consent form with that.
Okay, so Doxy does all of this.
Well, we added that to DoxyMe, and it became a telehealth. DoxyMe was simply a telehealth. It only included the video link. It's a lightweight video link, which is HIPAA standards-based product. It's lightweight and cheap to use. It's open source. So since Brandon, that's Brandon, by the way, and that's me over there testing the system. Yeah.
You're much better looking.
Thank you.
So, is there an issue with the kind of patient or the kind of research subject you would consent in terms of SES, equipment at home?
Yeah, definitely. Yes. Yes. Not only that, right now, Doxy.me does not support all platforms. We're still working on some mobile platforms. It was developed.
So you exclude Apple users? Is that a bias?
Actually, I think it does work a little bit with iPads, but not. But what it was developed and targeted for Chrome, the Chrome OS, and because it's lightweight and cheap, so it doesn't work very well on other platforms, and that's what we're rectifying right now. But it works very well on Chrome OS, and it's cheap, and so it's not a stretch to put a Chrome OS in a remote clinic to recruit patients.
Quick question.
Yeah.
You had a previous page that said no PHI. Is that for?
So there's no PHI in the middle. With Doxy.me, there's nothing stored on the Doxy.me server. There's only PHI on either side. So as soon as you disconnect the session, the data is lost. So you have to make sure you either print or save the data locally on each side. At least at this point, there's no. Eventually, we plan to capture the data like we were doing with RPMS, the first system I showed you. So we're trying to combine code from RPMS is also open source from both systems. And another system we're playing with is REDCap. I don't know if you know, but REDCap now supports digital signature as well. So we're trying to use that for a different use case. This is not for teleconsent, but we have like 3 or 4 researchers who are really, very hot on using REDCap for consent because it works really well within their workflow, and so they can bypass paper, they can store the consents electronically, they can start thinking about doing remote consent if it's a low risk study, and the best part is that in the field, it's easier if you have remote collaborators to do. They don't have to fax consent forms back and forth anymore. So there's a lot of benefits from using REDCap that are not being leveraged right now. So we are now working very closely with the IRB. We have good friends in the IRB, and it's key to, if you want to work with consents, e-consent, you have to be good friends with the IRB to approve a workflow that's compatible for both us and the IRB. And the trick with REDCap, although it has all these wonderful features, if you think about it, the IRB wants to see an IRB stamp on all their consent forms. So they want to be able also to give the final approval for any consent form that goes out that touches a patient. So we're trying to find a happy medium between the two of us that works with everyone. And they are eager because the researchers are not only bugging us, but they're also bugging the IRB for electronic consent. So hopefully we're going to be going live with this soon as well. We talked also, Brendan and I are talking about also using the REDCap API to put a telehealth interface on REDCap. All right, more infrastructure projects. So I mentioned SPARC request. I only mention it is because SPARC request is one of the things that made MUSC famous in the CTSA network. I don't know if you've noticed, but it was mentioned as an example in the RFA, and we were very proud of that in the CTSA RFA. So I think it was the XO2 RFA, I can't remember. But anyway, so SPARC is all about doing requests online for any type of research services. So it's helpful for research providers because everything becomes electronic. It allows investigators to budget their research and request services from the different places all in one place. It has a shopping cart paradigm. It looks something like this, where you can navigate browse for services. You can also search for services. It's a as you type, you start filtering here services, and then once you find your services, you can add them like you would add in a shopping cart. And in the end, you can, when you hit continue, that's when you're prompted to log in like you would on Amazon. And then the other things that it allows you to do is, if you have a multiple arm study, you can design your multiple arms. You can figure out what research services you want for each of the visits that you're working with. And then, as you can imagine, that can get complicated if there's a clinical research protocol that has standard of care expenses and research expenses. So this is very important to the compliance people. It's a big issue for the compliance folks at any institution. So what we did with SPARC is that we created an interface. As you know, neither Epic or SPARC is a CTMS. So there is overlap in data between the two. So patients are enrolled in Epic because that's where we track their medications and their orders and all of that. So the research protocols are moved to Epic after they are created in SPARC. And so we created an interface that uses standard. This is all the good reasons why you need an interface between the two. But we use the standard interconnect server that uses research protocol execution, which is an IHE standard for moving data into Epic. So the researcher now can create their protocols within SPARC. They can work on their billing calendar there, and we transfer all of that into Epic, where they can later, this is the data elements that are transferred over. I won't go through all of them, but they're the basic things like the study identifier. The people who are on the protocol are also moved over. Now we can move IDEs and so on. This is the workflow. The only thing to note here, so people work, the study team does their research. They work with in SPARC to create the protocol. Before they push their data into Epic, it goes through a sort of a check process, after which it goes back and it's reviewed by the study team. And once everything is approved, then it's pushed into Epic, and it goes live. So then they can start enrolling patients on it. This is just to show you the HL7 SOAP message that gets sent from SPARC for those of you who are interested. So now, I mean, the numbers don't look very big for a big institution, but for MUSC, it's a big. This was actually for a cancer informatics meeting, so it also shows the cancer protocols. But we have 680 protocols that have already gone through SPARC and into Epic, and we have about 4,000 patients recruited through those protocols within Epic. So SPARC, as you know, is an open source project. We have many institutions working with us now on SPARC. The red push pins are people who have already implemented SPARC locally, and the orange ones are in process. Not many of them are using the Epic interface, but they're all working on the CTSA request and metrics tracking pieces of it. Another infrastructure project I mentioned earlier is the IRB system. So we have a statewide IRB system that is run out of HSSC on Clemson servers. MUSC came on board with that in 2010. And our Biomedical Informatics Center, our group, runs the infrastructure for that. And so we're able to do a lot of nice things with it. These are the institutions participating in it. You know, if you're familiar with South Carolina geography, but you know, the active those institutions up here are quite, you know, Greenville is one of the most populous health systems in South Carolina. MUSC is based in Charleston, and we have Palmetto Health in Columbia. So, so we did a lot of work in harmonizing the work across all of these institutions. And what this allowed us to do is to develop a cooperative review across the institutions, which paves the way for IRB reliance. Because of that, the IRB applications look very similar across all of these institutions. So it became possible now to have reliance across these institutions. The other cool thing that we were able to do is, as I mentioned earlier, now there's a checkbox when you're doing your IRB application that asks you as a researcher if you want your clinical research to show up on this clinical trials registry. It's a local, it's sort of like the clinicaltrials.gov for South Carolina, but it covers, it's not restricted to just clinical, to trials. It has any clinical research in it. So it could be both drug trials or device trials, but also, you know, any other type of research volunteering that potential patients are interested in.
Does it have more detail than clinicaltrials.gov?
I wouldn't say it has more details. It's targeted for patients, so it has a layperson summary, and it has a keyword search system within it. And so it's more, I would say, participant-friendly than clinicaltrials.gov. But it doesn't have information about recruitment and all of that. It has contact information for recruitment, but it doesn't have metrics on recruitment, is what I'm trying to say. All right, so the next thing is research networking. Are we doing on time? Okay, so I don't know if you remember, but back in 2011, there was something called the Strategic Goal 3 within the CTSA network. One of the things that Strategic Goal 3, one of the recommendations they came up with is research networking. And they were encouraging a lot of the CTSA institutions to adopt products that support the Vivo ontology as a mechanism to share data across institutions. And to actually go ahead and share the data using the linked open data mechanism, which is a way to share semantic data on semantic web infrastructure, and to monitor that progress over time. So I was a participant in the SGC3 subgroup and also in the research networking group. And we worked, if you remember, Elmer probably remembers, we sent out a survey to see what CTSAs are doing. And then we took that data and we looked back in 2012. And it turns out a lot, because of those recommendations from the Strategic Goal Committee, a lot of the CTSAs, in fact, did adopt those platforms. And we found out that there's about 25%, at that time, it was about 25% using Profiles, which is an open source Harvard system. 21% were using Vivo, which, if you remember, was also funded by ARA funding through a U24 grant, along with Eagle Eye, if you remember, in those days. So Vivo was the research networking system, and Eagle Eye was resource sharing. So there was a lot of NIH backing for these, for sharing expertise across CTSA organizations. And then there was a quarter using the SciVal system. It was called SciVal Experts before it became Pure. And many were using homegrown systems. I have another diagram here, but if you're more interested, we did publish this here, but it shows things like levels of adoption, how many were using the Vivo ontology, and things like that. And so we're using Palmetto, we rebranded it as Palmetto Profiles, and it looks like many other profiles pages across the country, and it has many other ego surfing tools, I like to call them, where people can go see their network and who they're working for. You can look at your mesh terms and your word clouds, and you can also look at who you're working with across the state. We do have a couple of schools from Clemson who are on board with us. We have some also a couple of we have the clinicians from Greenville on board, and a few from Columbia. But certainly all the faculty at MUSC are on the system. The nice thing about those systems is, as I said, one of the recommendations is to be able to share this data across the CTSA network. So we expose our Palmetto Profiles SPARCL endpoint to federated query systems, although Direct to Experts actually does not use the SPARCL endpoint, but it does use its own API that can, so it has its own Direct to Expert endpoint that allows you to do federated queries when you go on Direct to Experts. The other nice thing about hosting your own system is that you can mine the data. So one of the things you can do, you can get a snapshot of what kind of research is going on across HSSC using word clouds. You can also do network analysis. So, and you can look at network evolution across multiple dimensions. Here is an evolution across time. So what I did is I took, 408 researchers back in 2005 through 2008, and then an equivalent period in 2010 to 2013. Because, if you think about it, the more researchers you have, the thicker the network is. So just to keep things equal over time, I chose 408 people at that snapshot in time, and another 408 in this snapshot of time, and tried to see if there's just thickness, increased thickness of the network over time. And I also balanced them to the same number of publications per person. And even with all of that balancing, you still see significantly increased connections. So basically what we're showing here is that there's a lot more team science going on than there used to be. Now, whether you can attribute that to the CTSA or not is another story. But there certainly is a lot more team science going on. And this is another different dimension, and this is basically taking those grants that cited CTSA and an equal number that cited other NIH-funded research. And again, you see a significant increase, not so much more, but you do see a significant increase in network thickness. This is yet another dimension which has a much more subtle changes, but this is the dimension of looking across departments rather than grants funded. So actually what we did is we looked at those that cited the CTSA and those that did not, and looking at how many of them were interdepartmental works. But that, I don't like that metric very much, because a lot of departments already have interdisciplinary people working within them. Like our surgery department has basic scientists in it. So it could be confusing looking at it that way. So you don't see a big change in that. I think I should hurry up. I'll stop in 2 minutes. So this is just to show there are, we have, I'm sorry?
7 minutes.
Okay, but I want to leave room for questions. Other initiatives, so this is a small research project I'm working on with the College of Charleston. I talked about this to some of you. So we're trying to look at our problem that we're trying to solve here is using the text data to automatically classify patients into certain diagnostic categories. And in this case, we're looking for lupus patients. And we're trying to look at different NLP algorithms married with different machine learning classifiers. And so, you know, we looked at, we used CTAKes versus bag of words, and for using neural networks, we found out that bag of words doesn't work very well, whereas when you're using random forests, it works really well either way, whether you use CTAKes or you don't. The other thing is, you know, this is just to show you of how our education has evolved. We started out without any informatics education at MUSC. Now we have, I teach a course within our Masters for Clinical Research. We also established a new Masters in Health Informatics that is led out of our College of Health Professions. We hired a new director for that is leading that effort. And then we have postdocs newly recruited within our center, working with research on that, and many other initiatives that we're working on, with some with College of Charleston, which is an undergraduate school within Charleston, but they have a computer science program. And other CRIO initiatives, you know, we're working with IBM on a precision medicine initiative. We're hoping that that will lead to bigger collaborations with IBM. Les Leonard, our new CRIO, is leading many initiatives within EPIC for research, like you know, a research registry for participants. We also have vended NLP systems for EHR phenotyping that is being married to the research registries. And this is my acknowledgement slides. So we're working with College of Charleston. This work would not have been possible without you know, my leaders. Dr. Brady is the PI on our CTSA. Les is my boss and CRIO, and our collaborators from MUSC and College of Charleston. So I'll stop here. Open it up for questions. Thank you. And thank you, Almer, for inviting me. I really enjoyed my visit here.
So with all these multiple sites across the whole state, how do you guys deal with the security?
It's a good question. We have as I said, we have an ISO that works out of Clemson, who works very closely with the different institutions. We also have a new ISO since you left, Jim. We call him, we have a new title called Chief Information Security Officer, who's superb. We got him from Ohio. And he's educating us on the different things like, you know, encryption in CETO and all of that good stuff. So we're trying to adopt that stuff at MUSC now also into Health Sciences South Carolina. But also the people at Clemson are, you know, like I said, they're very well experienced because they run the CMS database, you know, the Medicaid, Medicare database for the whole state. So they are experienced with that. And we run over VPN and all that good stuff, the data connections.
So this isn't so much a question, maybe a comment for you to react to. So as a preface, this is incredibly impressive how much you've been able to accomplish both within MUSC and even more incredibly, I guess, across the state.
Right.
So what's different about South Carolina, I guess is the question.
Yeah.
Where you were able to pull this off.
Okay, so yeah, I mean, I think it was the perfect storm. One is that we had some really visionary leaders that we were able to create Health Sciences South Carolina. Add to that philanthropic funding from the Duke Endowment. Add to that the smart state system that allowed us to recruit people. Both Ian was recruited, and I was recruited on that later on, and then we were able to recruit less on that after Ian left. And we created a new SMART. Those are sort of competitive grants that you apply for from different universities, apply for them, and statewide. And you can recruit people from out of state onto those smart state chairs. So we have that. And the other perfect storm is the ERA funding. It came about at the same time, which really gave us a real boost for creating Palmetto I'm sorry, RPMS, and we were able to recruit people, work with industry partners. At the same time, the CTSA took off at that time. But CTSA also, as you know, they have mandates across multiple institutions. Our mandate was across the state. So it worked very well it complemented health sciences. There was, there's always politics, so sometimes people step on people's toes, but we were able to work around those, and I think it worked well for us.
So maybe Ray can pull that off over here as well.
Yeah, I'm hoping, yeah, you should remind him what he did with, yeah.
I will do exactly that.
Yeah. Yeah, so.
Other questions?
So when you talked e-consent, you talked about partnering with industry and it not working well?
I'm sorry?
When you talked about e-consent,
Yes.
you talked about partnering with industry and it not working so well?
Early on, with RPMS, that project that was, we outsourced the initial development of our ontology. And what happens is that they developed the ontology without working with the development group that were working on the actual software, so they were disjointed efforts. And the other thing is that the progress on the software is not going as much as well as we would like. So we hired talent. That was another thing. We hired significant talent within our BMIC, Biomedical Informatics Center, that we were able to bring the code inside, revamp it completely, and push it out as open source. And that worked well for us.
Right. I think we're just about on time, Dr. Obeid. Thank you
Great.
very much.
Thank you. Now I can.
Now you can eat lunch. What's next on the agenda, do you know?
I don't know. He needs to get the airport by 2:30.
Oh, okay. All right, why don't we go downstairs? Yeah. Why don't we take you downstairs, put you into